Yesterday we learned how to add, subtract radicals. Guess what? What's next? We're gonna multiply them, and on Friday we will divide them. Okay? So multiplication looks pretty easy. You have two separate prisons, right? Two separate, and a dot between that means multiplication. What you do is you combine those inmates A and B prisoners under the same roof. You collect them into the same roof, and what is the operation you put between A and B? You keep that dot, kind of transfer that dot to between A and B. Multiplication happens between A and B. That's it. Roofs combine to one, inmates multiply. That's it. However, now that's not easy. That's the half of this question. You need to always look for simplifications, because when two population of prisoners come together under the same roof, what happens? They unite powers, they get stronger, right? And then they escape from prison, possibly. So you need to simplify those powers and get as many as out possible, okay? But sometimes even in each individual prison there may be some strong prisoners that they are ready to escape. So you always, it's a good idea to check if you can simplify the current product before you start multiplying. Like root, you have fourth root of 5. Do you think this guy can come out? Does it have any money or power around it? Does 5 have any power? 1, but it's not enough to bribe the guard. The guard wants $4. So no simplification on this one. Any simplification on this guy? 6. You can break 6 as 2 and 3, but they still have each $1. You need 4 for each guy. Nope, no simplification. So we are ready for multiplication. How do we multiply? All you need to do is make a bigger, wider prison with the same guard, 4, and put 5 and 6 inside. Okay, and multiply. Alright, and see if, since these two combined now, this is actually 2 and 3, are there any new powers showed up? Or I mean, there are 3 prisoners now. Can you combine them into make bigger powers and get some of them out? Is it possible here? No, they are all different prisoners, 5 to 3, with each of them having $1 only. They can't break prison. So once you're convinced that they can't unite powers and make bigger powers, all you need to do is multiply them out and present your answer as 30. Okay? So first question was pretty easy, because there wasn't any simplification required. Everything was already simple enough, and even you combined them, they were still simple. So all done. Again, fourth index, same index, just a bigger number inside. That's how you multiply two radicals if they are already simple enough. Well, not all radicals will be this nice. Coming up next, we have worse situation, 9 and 63, bigger numbers, right? Not 5 and 6. Let's see what's gonna happen. Okay, I will straightforward combine them into one, like that. Okay, by the way, I forgot to mention the condition to combine these two these two radicals into one. They must have the same indexes, so you can combine them into same type of prison. Alright, so same level prison must be required to be able to multiply. Alright, next. Alright, this is not a good idea. Most people think, oh, we need to straightforward multiply 9 and 63 and then simplify. No, don't rush to multiply these yet. I know you want to multiply 9 and 63, but hold on. Why? Because if you multiply this, you get 567, I believe. And this is a too large number to break. too large to break, right? When I say break, factor, this is too large. How are you gonna figure out all the factors? Why don't you factor them when they were tiny? Look, they are perfect 9 and 63 small abysmal numbers, so you can break them easier. So don't multiply yet. First break and see if you can save any one of the prisoners out. Then leftovers shall be multiplied. Okay. So this is an important fact. Once you combine prisons, don't rush into multiplying. First simplify, break, factor, check out powers, and simplify, then multiply. Okay, so can you guys break 9, please? Break the simple numbers. How do you break it? 3, 3. That's easy. So this guy turned into 2 pieces. There are 2 inmates there. 3, 3. How about 63? Yeah, let's do it right here first. It looks like 9 and 7. And then 9 splits again. And we have double 3 and a 7. So 63 split into 3 pieces. Look what happened. 2 groups of inmates moved into the same cell, same prison, and they are combining powers. They are making a bigger gang, right? Look, how many 3s do you count now? Earlier it used to be only double from 9. It was double only. Now how many do you have? 1, 2, 3, 4. Alright, look how rich this guy is now. He has $4 and you need only $3 to break prison. So you have $4, $3, the mandatory goes into 4 once. So you can save 1 guy from prison. And there will be somebody left in prison. This is left, this is out. So 1 3 coming out, 1 3 coming out, 1 3 remaining out, out, in. And how about 7? Is poor, is in. By the way, if the powers are all 1, you don't need to show them. There's something I'm missing though. The index. This is 3. Don't forget that. If you miss writing it, that reads as 2, which is incorrect. Are we done? Last thing you need to do is, if there are survivors in the prison, remainders, you need to combine them. So 3 times 7 makes 21 under the cube root. So it's 3 cube root 21 is the answer. Any questions? Perfect. Next. Alright, it's getting messier. What do we have now? We have some people already out of prison. They are free. They have their freedom. And some people inside. They are prisoners. So how do you multiply free guy prisoner times free guy prisoner combination? Any ideas? No, not necessary to FOIL. FOIL is required if you have addition and subtraction of stuff. Yes, you FOIL when you have pluses and minuses. Everything here is multiplied. So there are 4 items multiplying. Free guy 1 times prison times another free times prison. Everything multiplied, no plus or minuses, no foiling required. Easier than foiling. All you need to do is combine free guys among each other, multiply free guys with free guys, and prisoners with prisoners. So 6p times 2, what is 6p times 2? 12p. Since this is negative, it's negative. So this makes minus 12p. And the prisoners will multiply each other into same prison. You combine prisoners inside. It's Q, P, and Q. Look, Q, P, Q, Q, P, Q. Once you join two prisons, there's a bigger crowd inside, right? So possibly they unite powers and break prison, correct? Anything such thing happening here?
Yeah.
Yeah. Do you see any same term twice? Aren't these two same? So can I make a square out of it? Q square P. Oh, God wants $2. This guy has $2. 2 take away 2, 0. When you divide 2 by 2, nobody left inside, and this guy is out. One Q coming out, this Q coming out, and nobody left there anymore. So we have minus 12 PQ square root of P only. Can you follow? Basically, you're combining these Q's into Q square and taking it out because they have the money, $2. Okay? Makes sense? Thank you. Alright, same deal. Free guys. Who are free? These are free. Everything multiplies each other. No foiling required. Free. And prisoners, a lot of prisoners this time. Not just P and Q's. It's pretty crowded prison 1, pretty crowded prison 2. When you combine them, I think they are going to be overcrowded and they will start escaping. Alright, I'll give you a second to think about this. Okay, I will show you two approaches, methods to this question. First, the standard way we did. Use the present format and multiply free guys first and then combine prisoners, right? So 4 times 7 is 28, negative 28 as you guys said. And in the prison you have a lot of people inside. It's 3, 6 first, 3 and 6, and then r squared and another r squared, s cubed and s squared. Oh, these are same base things, so we can combine them into bigger powers. So those guys are joining up, teaming up, making bigger powers, richer. Look, this guy is really rich now. This guy is really rich as well. And by the way, this 6, yeah, 3 and 2, so you get 3 squared. Yes, 6 is 3 and 2. I can break this guy as 3 and 2, so it's 3 squared and 2 actually. So 3 is teaming up with this 3, 2 is alone, however. That's fine. Now let's see if rich guys can break prison. God wants $2, this guy has $2, yes, this is all out as 3. 2 remains because he has no money. 4 is rich. God wants 2. 4 divided by 2 is 2 goes into 4 twice and makes 4, and nobody left. This guy is completely gone. How many of them will show up outside? There are 2 of them. It's r squared. So this guy comes as r squared here. And this 5, 2 goes into 5 twice, 1 left. One of the s's will stay in as to the 1. two of the s's will escape. So r squared, s squared, 28, and 3 times of it is the free guys now. But what is 28 times 3 now? It's 84. I believe 3 times 20 is 60. 3 times 8, 24. 84. S squared, r squared, or r squared, s squared. In the square root, you have 2 left, and one of the s's left. Okay? Correct. Okay? Did you understand this method? There is a better way. I don't want to classify better or worse, but there is another way if you prefer that way. So we copy this question. Look, I already observe rich guys already. Before combining these prisons, why don't you save some of these guys from prison? Like r squared will break prison and go away as r. S cubed is 2 goes into 3 once. One of the s's will stay in, but the other s, one s goes out, the other s remains. S comes out. So the first group becomes 4rs, and only thing survived inside is 3 and s. 3 is left, 1 s is left. How about this prison? Look at this. R and S both have the exact change, $2 requested, so they come out as R and S. R and S. So it's minus 7RS. But who's left inside then? 6 only. And 6 has no money, it's just 2 and 3. You may want to put this as 2 and 3 though. 2 and 3 are stuck inside. Look, now you have a bigger crowd of free guys. Free, and you can join them. 4 times 7 is minus 28. R times S is double. R squared, S squared. In prison, you have 3, S, 2, 3. However, once these 2 3's combine, they come out as 1 3 because this is 3 squared. Exact change got 1, so they cancel, and 3 comes out. So what remain? And 3 and 28 combines into minus 84. R squared, S squared, 2s is what's left here. Same result, different approach. So what did I do? I first cleaned up the prisons, then combined them. Rather than earlier, I just combined the free guys and 2 crowded prisons combined into much crowded. I feel pretty much the same work. Not one side is not easier than the other, but you can try both ways. Okay. First clean up, then multiply, or multiply first, then clean up next. It's your choice. Okay. All right, you guys. Let's start this one. Wow, this is a triple prison situation. Can I combine all 3 prisons at once? Yeah. Everybody moves in. All 3 prisons, everybody inside will be carried into one bigger facility. Make one giant prison and move everybody in. That's it. Or before you start moving things inside into new prison, you may want to clean each prison. See if you can save anybody out of prison before you start. I see somebody, for example, but that's not necessity. You can avoid doing that until you combine prisons. I'd rather do it later on this question. Nothing? Say it if you have an answer.
AB to the cube root.
Mm-hmm.
144 a squared b squared.
Any different answers? I have a feeling 144 is too big. You may save some people out of 144. I don't know. Maybe I'm wrong. Let's see. Alright, I broke already all those numbers inside. 8 is 222. 4 is 22. 36 is first 4 and 9, but 4 splits into another pair of 2's. And 9 splits into 2 3's, double 3's, right? So we have 1, 2, 3, 4, 5, 6, 7 2's. 7 2's together when you join every inmates in the under the same roof. 1, 2, 3, 4, 5, 6, 7 2's. How many 3's? Double. How many A's? Double A, triple A, fifth, 5A, fifth power. Look, 2 A's here, 1 more 3, 2 more 5. I'm combining everything. Single B, 3 more 4, 1 more 5. That's B. Anything I'm missing? Anything? Okay. Can I, instead of all these separate 2's, can I make it 1 power out of them? So, oh god, how many again? 7, right? Don't lose count. That's 2 to the 7th. How about 3? This is not necessary, but I still want to do it. It's 2. I'm gonna change everything into power. See how rich they are. Oh, this guy a lot of have money, right? 7. So he's gonna break prison. I'm wondering how many 2's comes out, how many it stays in. So you need to do long division for that. 7 divided by 3, right? 7 divided by 3. How many times 3 goes into 7? Twice. 2 times 3 is 6. 1. So 1, 2 remains in. 1 remains in. How many comes out? 2. 2 out. How many 3's remain in? How many comes out? He doesn't have enough money. All in. So this guy is gonna stay in like 9. You don't need 3 squared anymore. It's 9. How many A's comes out? How many stays in? 5 divided by 3. 3 goes into 5 once. 2 stays in. This turns into A squared. 2 is in. 1 is out. 1 is out. So that means A to the 1 coming out. Same deal. This is 5. So I believe 2 of them will stay in. Red ones are in, blue ones out. 1B coming out. Because it's the same 5. You do the same work. 2 in, 1 out. So let's collect everything we have. 2 squared, which is 4AB. 2 remains. 9 remains. A squared, B squared. But we better combine this. 18. 4AB. 18A squared, B squared. Almost, okay? You need to pull 1, 4 as 2 out here. Okay? I'm sorry, ConnectMath is very picky. If you leave your answer like this, it's say incorrect. All this work will go to trash. That's why I'm working really slowly, counting every power and computing it. Go slow, don't make mistakes. I don't know, let's check if it's gonna like your initial answer. 2AB cube root 144 you said. AB, right? A squared, B squared. Look, it says incorrect because we didn't simplify 144. Now we go. Alright, coming up next. Oh, things turned simple. Instead of a very difficult question, it looks like we have a very nice looking question now. There is a trouble waiting for you guys here. Let me make things visible for you. When you see a parentheses like this, and especially an addition inside, that calls for trouble. What kind? Again, you had parentheses before. We didn't have issues with that, right? Like this parentheses. I didn't warn you about trouble here because everything was multiplication here between terms. Everything was smoothly multiplied. So parentheses were redundant. You can wipe them off here. But not there. This parenthesis is necessary. That means this single term is multiplying not only the first guy but the second number as well. They are joined together with a plus. When you see a parenthesis, a plus or minus in the terms, it calls for distribution law. This is called distributive property. So you need to first put this number outside in front next to each guy, distribute to each guy. So 3 root 3 and 5 root 3 comes together first, and then we put this plus in between and compute the second half, this one now. 3 root 3 will go next to 2. So I'm doubling 3 root 2 into 2 locations. One, twice. One with the first guy, one with the second guy. Is it clear? And then this is called distributive property application. We will perform multiplications as before now. There are multiplications to be done here. How? 3 guys with 3 guys combine first. What is 3 times 5? Then you combine the presents. Inmates move in and they combine powers and may break prison. So do we have a break prison situation here? 3 square, right? Oh, look at this. They have the exact change. So 3 comes out completely. 2 and 2. 2 divided by 2 is a 0 remainder. So they cancel away. 3 comes out. It makes this thing 3 times 15, which is 45. That's the first half. We have another part coming up. Now how do I multiply this thing? I'm confused. There is a single prison and 2 free guys here.
3 times 2 and 3
Yeah.
times
You only combine free guys then. Prison has nothing to combine with. 3 times 2 is 6. 6 root 3. Alright, can I simplify anything here? And no. It travels with, wait a minute, what is this? 45, right? It looks like 4 times 5. Just join really together. 45 plus 6 root 3. Okay, question. Can I combine 45 and 6 and make 51? They are adding 51 root 3. No, this is false. Why? How come we can't add two numbers? There is a plus between. No, this 6 is not free. They are glued together. They are one part. 6 is a part of a whole body. 6 and root 3 goes together. Okay? The only way you can add 6 root 3 with something else is if that something else has the same root 3. So they are like, these are like now. You can combine the numbers in front and make 51 root 3. But this is not working out here because we don't have root 3. Only this is a whole number. This is a number radical combination together. They are not like. So you cannot combine them. That's your final answer. 45 plus 6 root 3. Okay? Any questions? This wasn't too bad. Because you had only one number in front versus addition of 2 items. I believe we will have much terms coming up next. What is the difference in number 7 now? Yeah, this time just basic distribution is not gonna make it. Why? Look at the parentheses. They are multiplied and there are additions inside. Like A, B, C, D. A plus B, C plus D. This is a 2 term by 2 terms. There is 2 terms here, 2 terms. If you have 2 terms on each side, this requires FOIL, FOIL. Why don't we do that here? Because this is single term versus 2 term. Single 2 term is easier. You just take the single term to each term. Single versus 2 term, 2 term versus 2 term. This requires complete foiling procedure. F as in first terms. So these are the first terms. This is F. O means outside terms. Outside terms are these. The ones on the corners, on the far ends is O. I is inside terms. The ones in the center is I. This is the center terms. I should use a different color. This is I. L, last terms are the ones on the right sides of each parenthesis. Right sides are these. Let's use purple. These 2 are L, last of each parenthesis. Okay, let's do it.
So you're doing for F, would you be doing 7 times 1 or would you be doing 7 times 5?
Good question. So 7 is free. There is no free guy here, but there is actually a secret one. So you can do 7 times 1. So 7 times 1 is 7. And you combine prisons. Root 5 times root 5. Free guys first, prisons next. Which make double 5. Whenever you have a double in square root, they come out as 5, okay? So can I do these steps faster and just simply say root 5 times root 5 is just 5? Again, this is what I did. 5 made 5 squared, but 2 match, nobody left inside, but 5 is out, right? So this is 7 times 5. Do you see that? 7 times 1, 7, root 5, 5, as explained here. That's F. Let's do O. 7 times 6, 42. Look, 7 and 6, free guys. Then inmates, but they make 5 and 3. 5, 3. Can you save any one of these out? They don't have money. 5 to the first, 3 to the first. But even they combine, they don't still have enough money. So I will just call this 15 then, because they have no promise to escape. 42 in front there. Okay, let's do I. We did O, right? F-O-I. Where is I? Root 3. 1 root 3, 1 root 5. 1 times 1 is 1. Root 3 and root 5 makes... Oh, same couple showed up again. So I bet they will make 15, right? Okay. And last, who can tell me the last? L. It's 3. What happened to 6? Look, 1 times 6 is 6, and you have double 3. That's a square. This thing is 3. So this is 3. Don't forget 6. 3 times 6 is 18, right? Okay, looks like we're done here. 35, 42 root 15, another root 15, 18. Is this our final answer? No. We're still one step before the final result. What is last step? You need to simplify this as much as you can. Combine like terms. These are like, right? 35 plus 18 makes how many? 53. And then that's it. Right? We just copy these two. We're out of like terms, right? Are we out of like terms? Are we out of like terms? What are these called? They are like as well. Remember, back to yesterday, when you have two radicals added, you can only add them if the index of the prison and inmates match. Don't you have root 15, 15, same thing twice? So they are like. All you need to do is add the numbers in front. They make 43 of them. 42 apples, one more apple makes 43 apples. This is the best answer. And again, anything other than this answer is accepted incorrect in Connect Math, so be careful. Okay, we have 3 more questions left, so why don't we take a break until Friday?